All right, so this is January 2020, question number 10. A says the transformation M, which is 0p Q0, maps the point R onto R prime as shown in the diagram below. All right, so we have the points R and the points R prime. What I would recommend here is that you simply just note the coordinates of R. R is the point 2, minus 5, and R prime is the point 5, 2. All right, so that's all we need from this page. So we're asked to determine the values of P and Q. So the transformation M, which is what? 0P Q0 is applied to R, which is 2 minus 5, and it became R prime, which is 5, 2. All right. So let's find out what P is and what Q is. Let's multiply. 0 times 2 is what? 0 times 2 is 0. P times minus 5 is minus 5P. Bottom row, same column. Q times 2 is 2Q. And 0 times minus 5 is 0. All right, and this is equal to 5, 2. Now, when two matrices are equal, corresponding elements are equal, therefore minus 5p at the top is equal to 5. Divide both sides by minus 5. And we get p is equal to minus 1. Down by the bottom, 2q is equal to 2. Divide by 2, 2. And here q is equal to 1. So p is equal to minus 1 and q is equal to 1. Then we're asked to describe fully transformation M. So transformation M is 0, minus 1, 1, 0. All right, what this matrix does is that it interchanges the x and y coordinates and it changes the sign of the new x coordinate. All right, so M is R O positive 90 degrees. This is a clockwise rotation of 90 degrees about the origin. All right, it's a clockwise rotation of 90 degrees about the origin. In order for you to arrive at that conclusion, you've got to have a rough idea as to what happens for the different types, for the standard, for the different types of standard transformation. What happens? All right, when the x and y coordinates interchange and the sign of the x coordinate change, what type of transformation is that? All right, so the vector part of the question, this says PQRS is a parallelogram in which the vector PQ is U, the vector PS is V, and M is a point on QS such that QM, the ratio of QM to MS is 1 to 2. All right, so it's almost as if the entire line QS is divided into what? 3 parts. QM is 1 part of the 3, and MS is 2 parts of the 3. So the first thing we're asked to do is we're to write in terms of U and V an expression for QS. So using the triangle law of vectors, the vector QS is equal to the vector QP is equal to the vector QP plus the vector PS. This is the triangle law of vectors. I'm going to start at Q and end at S, and the next letter is in the middle. PQ is U, so QP would be minus U. So this is minus U plus V. I normally like putting the positive one first, so this is V minus U. So QS is V minus U. QM, everybody should remember that QM is equal to 1/3 of the vector QS. So this should be 1/3 of V minus U. All right, next, we're to show that MR is equal to 1/3 U plus 2V. MR, so let's go for MR. MR is here. MR would be equal to MQ plus QR, or you could say MR is equal to MS plus SR. If over here is U, over here so is also U. All right, I think I'll go that route. So I'm going to tell the examiner that MR, the vector MR, is equal to MS plus SR, and this is the triangle law of vectors. MS is 2/3 of QS, and SR is the same as PQ, is the same as the vector PQ. So this is 2/3 of V minus U plus PQ, which is U. The LCM is 3. 3 into 3 is 1. 1 times 2 is 2 into V minus U plus 1 into 3 is 3. 3 times U is 3U. So therefore this becomes, therefore MR would be equal to 2V minus 2U, and this is plus 3U. And this is all over 3. So this is going to be 3U minus 2U plus 3U is U plus 2V over 3. Now dividing by 3 is the same as saying multiplying by 2. Dividing by 3 is the same as saying multiplying by 1/3. So this is 1/3 U plus 2V. We're asked to show that, and we did. Then lastly, we're told that T is the midpoint of PQ. So let's go back. T is the midpoint of PQ. That's T. And I'm guessing they're gonna ask us to show that T, M, and R are collinear. All right, T, M, and R are collinear. So we're to prove that R, M, and T are collinear. So to do that, the first thing I'm going to find is TM. We have MR already, so I'm finding TM. TM is equal to TQ plus QM, sorry. This is equal to 1/2 of PQ plus 1/3 of plus no, we already found OM. I think we did. Yes, we did. OM is 1/3 V minus U. So it's 1/3 V minus U. So this is a half V plus 1/3 V minus U. The LCM is 6. 3, this is 3V. 2 V minus U. So this is 3V plus 2V minus 2U. All right, let's just double check to ensure we're not making a mistake. Or actually, it's not V, it's U. PQ is actually U, not V. Right, because something looked like it was going wrong. So this is supposed to be U here and not V, U here, U, and U here. All right, very good. So this is U, and so this is over 6. So Tm, the vector Tm, would be equal to U plus 2V over 6, which is equal to 1/6 U plus 2V. So T, M, and R are collinear because Tm and Mr are parallel and they share or have a common point, have a common point M. So two vectors are in a straight line if they are parallel and they share a common point. The common point that they share is M, and the two vectors are parallel because they are scalar multiples of the same base vector. If you look carefully, this is 1/3 U plus 2V, and this is 1/6 U plus 2V. That makes them parallel. Now, if they are parallel and they share a common point, the common point is M, they form a straight line. So T, M, and R are collinear. And that's the end of the question.